Okay, hi, thank you for joining me. In this video clip, I'm going to look at numbers 7 and 23 on the semester exam study guide, both dealing with using trigonometry. On number 7, at first look, you may want to think that this is an altitude going to from the hypotenuse of a right triangle, but it is not necessarily. It's not given that this is a right triangle, so I cannot treat this altitude as a geometric mean. Okay? So in this problem, we're looking for x, the length of the leg of this triangle here. All right, if you look at what we have, we only have the length of one side, so I cannot use the Pythagorean theorem like I'm used to because I need two side lengths to use the Pythagorean theorem. But if I look over here at this smaller triangle, I have enough information using trigonometry to find the length of this leg. And with the length of this leg, I can use either, again, trig or the Pythagorean theorem to find x. So that's what I'm going to do. And I can use the 60-degree angle or the 30-degree angle. I'm going to use the 30-degree angle. And from that 30-degree angle, I want the opposite leg. I want the length of the opposite leg. I have the length of the adjacent leg. So that tells me opposite over adjacent. I'm going to use the tangent ratio. So the tangent of 30 has to equal opposite over adjacent, or a over 5. I'm calling this unknown length a. So now I need to realize, okay, this tangent of 30, it's some ratio, okay? And remember, with every right triangle that has a given um, angle, a given acute angle that's fixed, all those right triangles are similar. So the ratio of tangent 30 should equal this ratio, and I need to find the value of a that makes this ratio complete equal to this one. So I'm going to get a by itself by multiplying 5 to both sides, and end up with a is equal to 5 times the tangent of 30. When I take the tangent of 30 with my calculator or with the table in the textbook and multiply it times 5, I get approximately 2.9. Now I'm ready to use the Pythagorean theorem to solve for x because I have two sides of a right triangle. So a squared plus b squared is equal to c squared, or a squared plus x squared is equal to 12 squared. Okay, so when I substitute my values and I follow my order of operations and solve, I get approximately 11.6 for x. Okay, now let's look at number 23. If I can find that one. Let's see, that's 18, 19, 20, 21, 22, 23. Okay, I'm not going to take the time to read through all the extra detail of this problem, but basically what we end up with is a right triangle where we're asked to find the measure of angle x that makes this part of this right triangle with these dimensions. Okay, the driver of the boat wants to change direction to sail toward the restaurant. Which of the following is the closest to the value of x? So in everything we've done so far, we've been looking in our practice with trig ratios, we've been looking for an unknown length, either the hypotenuse of the leg. This time our angle is unknown. All right, but when I look at my angle and I look at what's given, I have the opposite from the angle. I have the opposite leg length and the adjacent leg length. So that's the tangent ratio. So the tangent of some angle, we'll call it x, has to equal 32 over 77. So think back to the table we looked at. We can go both ways. We could go from the angle to the trig ratio values, or from the trig ratio values to the angle. Okay, and so our calculator can do both. So the way that I get my calculator reverse to go from ratio to angle rather than angle to ratio, I use what we call the inverse tangent key. Okay, it's tangent to the -1. So I can select that key and put in my ratio 32 over 77, and I will get 22.6. So let me show you what that looks like on the calculator. All right, it looks different on different calculators, but with the calculators that we commonly use, again, I want the inverse tangent. So notice under tangent, I've got the green tangent to the -1. Okay, that means 1 over tangent. Okay, we're reversing everything. So I'm going to push the second key to access the inverse tangent key. And I think it was 32 over 77. I don't have to close my parentheses, but I will. And so the calculator is going to convert that ratio into what the angle measurement would be for those corresponding side lengths of a right triangle. And that is approximately 22.6, which we see here. So this angle here for the driver would have to be 22.6 degrees approximately.